Hi guys, today we're going to talk about exponential functions with rates. So in exponential functions, a rate is the percentage of growth or decay. Another way that we can write exponential functions when we have a growth or decay rate is a sub 0 times 1 plus or minus r to the x power. Now if you'll remember, a sub 0, that's our start value. Okay, that's how much we're starting with. Also our y-intercept. B is the factor. We've been talking about factors since we started in this unit, okay? So, but this time, in order to get our factor, we have to add or subtract the rate from 1, okay? So R is our rate, and usually when we see a rate, it's going to be in percentages. We're going to have to take that and change it to a decimal. All right? So remember, B is the growth or decay factor in the exponential function, but the rate is the percentage of growth or decay. So if we have a growth factor, or define the growth factor, we're going to add the rate to 1. So it will be 1 plus our percentage. Okay? If we have a decay factor that we need to find, then we're going to take 1 and we're going to subtract our rate. I was waiting for my R to disappear. Hey. Okay, so 1 minus R. All right, let's go ahead and flip to the back. Let's look at a couple of examples. Okay. Example 1, in 1990, the population of Washington, D.C. was about 604,000 people. Since then, the population has decreased by 1.3% per year. What was the population in 2017 if this trend continues? Okay, so let's find information that we need. We know we need our starting value. So our starting value is right here, the 604,000. Okay. We're given a rate, we're given a percentage. So this is going to be our R. Okay. So our starting value is 604,000. We said our rate is 1.3%. We're going to have to change that to a decimal, so it's 0.013. Okay. Now, we need to decide if it's a growth or a decay. So let's look at the board problem again. So since the population has decreased, that's our keyword that tells us it's a decay. Okay, anything that indicates it's going down is going to be a decay. So for our factor, we're going to do 1 minus 0.013. That's going to give us a factor of 0.987. Okay? So our function is going to be 604,000 times 0.987 to the x power. It's asking for our asymptote equation, and if you remember when we started on exponential functions, I told you that for Algebra 1, the asymptote equation is always going to be y equals 0. Let's know what was the population in 2017. Okay, so we need to figure out how many years from 1990 have passed to get to 2017. So that's going to be our x value. So x is going to be 2017 minus 1990. Okay? So 2017 minus 1990 would be 27 years. That's going to be our exponent. So 604,000 times 0.987 to the 27th power. Let's look at our calculator, okay, because this is not one we could do in our head. So, whoa. Okay, 604,000 times 0.987 to the 27th power. Okay, this is going to give us 424,228.71. We're talking about people, so we can't have part of a person. Okay, so we're just going to go ahead and round this to the nearest whole person. So 424,229. Okay, so when we go back to our notes, 434,200. Oh, my 3 disappeared. 434,229 people. Remember, we need to write our units in there. Okay. All right, let's look at example 2. A city's population increases by 4% each year. If the current population is 235,000, what will be the population in 30 years? So again, we need to find our a sub 0, our start value, and that's going to be the 235,000. 235,000. Our rate is the 4%. Okay, so we've got 4%. When we change that to a decimal, we get 0.04. Now we need to decide if it's growth or decay. So the key word here is increases. That tells us it's a growth problem. Okay, so we're going to add. So 1 plus 0.04. Okay, which is going to give us a factor of 1.04. It's 1.04. You know what? I forgot my start value, didn't I, guys? Hey, what would it be if Miss Johnson didn't make an error or two throughout the day? All right, 235,000 times 1.04 to the x power. Okay, again, our asymptote equation is going to be y equals 0. Wants to know what was the population in 30 years. So we're going to take that 235,000 times 1.04 to the 30th power. So 235,000 times 1.04 to the 30th power. So this city in 30 years is predicted to have 762,198.4149 people. Again, we can't have a part of a person, so we'll round to the nearest whole person. And so 762,198. Okay? So 762,198 people. All right, guys. Just 2 more examples we want to go through today. And this is when they give you a table and they want you to find all this information. Guess what? We could put it in our calculator. We could use stat edit. Okay. Now I am going to tell you there's an error over here. It is not number 5. Number 5 in that menu, in the stat calc menu, is for quadratics. We're actually going to look for number 0. It says EXP reg, and I'll show you where that is in the calculator. Okay. So let's start by putting example 3 into stat edit. Okay, so we're going to go over here to Stat and Edit. My X values are okay, but I have different Y values. So I'm going to go up here to L2 and hit Clear and Enter, and it will clear that list for me. And then I could go on in and repopulate my list. So, and 4. Okay. Once we have it in L1 and L2, we can come over here to Stat again. We want to go to Calc. And you won't see EXP reg on here. You see it goes 1 through 9, but there's an arrow at number 9. So that means that we're going to have to go down. That means there's more menu that we're not seeing. And this is the one we want, the 0. Okay. So EXP reg, that's exponential regression. X list is L1, Y list is L2. And because it wants us to find what f of 12 is, we're going to go ahead and store our equation. Okay, so alpha, trace, and number 1, and we could store our equation in y1. And then we can just go to the table to see what the equation is. All right, or what the y value is. So A is 64, B is 0.5. Okay, so our A sub 0 is 64. Our B is 0.5. Now, if you notice, all of the y values here are decreasing. That means that this is a decay problem. Okay, so if you remember, to find our B value for decay, it's 1 minus the rate. Well, we're given a B value, and we need to find the rate. So 0.5 equals 1 minus R. We will subtract 1 from both sides and get negative 0.5 equals negative R. And when we multiply or divide both sides by negative 1, we get positive 0.5 equals positive R. So our rate is 0.5. Now, the factor and the rate are not always going to be the same. 0.5 is that exception. Okay? So our function is 64 times 0.5 to the x power. If we go back to our calculator, we could see what the value is when x is 12. So let's go look at our table. And when x is 12, down here, it is, the y value is 0.0156. Okay? So 0.0156. All right, now let's look at our example 4. This is the last example. We're almost done, guys, and then you can work on the assignment yourself. So let's go back to our stat and our edit. And in L2, again, just go up to where it says L2, hit the clear button, and then the enter. And you can repopulate it with the y values from that table. The x values are still 0, 1, 2, 3, and 4. Okay. 15.914, 16.391. And if you notice, all of our y values are increasing. They're getting bigger. So this is going to be a decay problem. Or excuse me, this is going to be our growth problem, not a decay. I apologize, guys. Okay. And once again, we can go to Stat and Calc. And remember, the exponential regression is all the way down here at the bottom. It's option 0. Okay. And store reg EQ again, alpha, trace, and 1. And then we can calculate. So our A value, now there's a lot of decimal here. If we just round to 2 decimal places, for our A, we're still going to get 1. For our B, we'll get 1.03. Okay, that's all we need. So A is 15, B is 1.03. Now I told you that as our x values are getting bigger, so are our y values. This is an increase, which means it is a growth. So to get B, we had to do 1 plus our rate. We're given B, so we're going to do 1.03 equals 1 plus whatever the rate is. So to find our rate, we're going to subtract 1, and we'll get 0.03 equals R. So our rate is 0.03. Okay? Our function is 15 times 1.03 to the x power. And if we go look at when x is 12, if we go look at our table, when x is 12, our y is 21.388. So 21.388. All right, guys, you have your assignment. Okay, you're working on some of these. You've got some on the front and on the back. So get busy on them. If you have questions, you can text me through the Remind app. Okay, just make sure you let your sub know that's what you're doing so they can monitor and make sure that everything's on the up and up. If I hear that you're on your phones constantly and I'm not getting texts from you guys, there will be a problem. All right. See you guys tomorrow and have a good day.